All right. So we talked about sodium benzoate, and you kind of know the good things and the bad things a little bit about sodium benzoate and some of the reactions. So the issue here is that should you be afraid of sodium benzoate? Yes or no? And it really depends on who you talk to, because some people will go crazy with all of this stuff and they will try every way in the world to convince you that you're going to die of a horrible, long, and painful death if you eat sodium benzoate. And other people just really don't care. So, should you be afraid? Is it really safe? Um, you know, I'm going to give you some facts, but I'm going to let you make up your mind on that kind of case. But good luck trying to get away from sodium benzoate, because I guarantee you it's everywhere. Every kind of consumer product that you're going to pick up, I want you to look on the ingredient list and you're going to see a preservative. And sometimes that preservative is sodium benzoate, and sometimes it's another preservative, but a preservative is going to be present. Sodas, pickles, juices, anything really on a consumer shelf will probably have something similar to this. So good luck if you want rid of all of it. Over there on the right hand side, you're going to see basically a vitamin. It's a multivitamin. And if you look on the other ingredients, it's going to say purified water, polysorbate 80, propylene glycol, glycerin, natural cherry flavor to make you feel good when you drink it, potassium sorbate, and then the next one, sodium benzoate. So it's either in multivitamins. So again, good luck trying to completely get rid of a preservative in your diet. Now, a lot of people, they don't like it because, again, they look at it as a chemical and they say that you should not be putting chemicals in my food products. So here's a nice little comic, and it's this woman, maybe at a bake sale, and it says artisanal sodium benzoate. Come and get it. It's going to be great. As a rule, ho-hos should not be enjoyed out of season. Why ho-ho? Well, they're kind of like Twinkies. When is the last time you saw a Twinkie get mold? Right? So over to the side, it says Monica's farm to factory to table to toilet startup. So good news for you as a consumer. Now, issues. Why did all of this get started? Why are we so concerned with sodium benzoate? Well, the key here is benzene. Benzene. Benzoic acid. And remember I said that benzoate represents the benzene structure. And the benzene structure, once again, is this six-membered ring with a circle, right? That's benzoate or benzene. The issue here is that this can kill you, and it has killed people in the past. So you're trying to tell me that sodium benzoate, so poor benzene drinkers. Well, who's going to drink benzene? I mean, just because part of the molecule similar to the benzene structure doesn't mean that it's actually benzene, right? That just means that it's kind of like a cousin. But we already know that one change of an atom can completely give us a different type of molecule. And this is one change of an atom, at least a big one. It's not just the benzene ring. And who's going to go and drink benzene? Well, knowingly, at least. Well, what's sad is that many people drank benzene, and they didn't know about that they were drinking benzene. So in 1990, we see reports that show certain soft drinks had very low levels of benzene that were present. Perrier was the first product to show it. And they voluntarily recalled their product from the consumer market until they figured out what happened. And then soft drink companies began to generate reports, and they sent it to the FDA to allow the FDA to review these reports. How did benzene get present in the soft drink? 3 years later, FDA said, well, we reviewed the soft drink reports that were voluntarily given to us. And what we actually found is that there was benzene in your soft drinks. Congratulations, you just drank a molecule that causes cancer. Well, how did benzene get there? Because companies like Coca-Cola are not going to deliberately put benzene into your product. Could you imagine? So it had to be present through some type of mechanism, through some type of chemistry or reaction. And what they discovered in 1993 is that the benzene was getting present due to a reaction between sodium benzoate, the molecule that you're going to be working with in this lab, and vitamin C. Vitamin C is also called ascorbic acid. So we have a sodium benzoate that's present, and we have ascorbic acid that's present, and there's a reaction that goes on between the two, and when that reaction goes on, benzene is generated as a product. Kind of scary. Well, this means that vitamin C had to be present as well. So in 1998, numerous soft drink companies pulled their products due to very high levels of benzene that was found in the product, and the majority of those were vitamin C based as well. Well, what kind of things have vitamin C? Well, these are typically your citrus flavored soft drinks. Crush, Sunkist. But soft drinks weren't the only thing that was targeted. 2006, an unnamed chemist at the FDA revealed that many orange-flavored drinks had high levels of contamination. 2006, UK's FDA, they don't really have an FDA, but the equivalent to it, tested 150 beverages. 43 of them had benzene, people. 4 of them had levels above 10 part per billion, which is severely contaminated. 2006, Korea's version of FDA detected 27 products out of 30 with high levels of benzene. Some had 80 part per billion. And to date, 2016, 2018, whatever year you're watching this video, the US FDA has tested over 200 soft drinks and has reported that only 10 have levels above 5. And 5 is the level that's set by the EPA, not FDA, for environmental benzene contamination. Great, huh? We're going off in an environmental standard for a consumer product that you should be eating. Does that really make sense? So here's a quote. And the quote says, "The FDA is working with the beverage industry to minimize benzene formation in products. For example, FDA has met with industry to determine the factors contributing to the benzene formation. FDA has directly contacted those firms whose products were tested and found to contain more than 5 ppb benzene in our survey. Manufacturers have reformulated products to ensure benzene levels are minimized or eliminated. The International Council of Beverage Association and the American Beverage Association have developed guidance for all beverage manufacturers on ways to minimize benzene formation. FDA will continue its testing program for benzene in soft drinks and other beverages to monitor levels and will inform the public and manufacturers as new data become available." Whoa. Right? The FDA is going to tell me that they found 10 products, just 10 of 200, that had high levels of benzene, when these other countries are finding 43 of them out of 150, 27 of them out of 30, but for some reason in the United States, only 10 of 200 tested positive. And then the FDA is going to make a statement that says, we are working with companies. That way they will know how to minimize benzene concentration. Not eliminate it, but minimize the benzene concentration. So again, it's okay if it's present. It's okay if it's there. It should be less than 5 ppb. And we're going to just continue to monitor these things as time goes on to make sure that we feel okay. And if there's something that ever shows up, then we'll let you know. Trust us, we'll let you know. What? I'm supposed to be living in a civilized world. So benzene is regulated at 5 ppb by the EPA in drinking water. No regulations are placed on soft drinks. This is a soft drink, it's not drinking water. So they're just using 5 ppb as a guideline, as a measure to determine if something's contaminated or not. But because this really doesn't classify as drinking water, it classifies as a soda or a soft drink, they do not fall under the drinking water standards. All of this is voluntary based. All of this is by the goodness of their own heart. And to date, they still haven't really fixed the soft drink regulation. So what's going on? Sodium benzoate is combining with vitamin C in a product that has vitamin C. And through the storage process and through the heat, through the transportation process, what you're finding is that the heat is providing a catalyst for this reaction to go forward. And this heat is converting the sodium benzoate over into benzene. 2008 comes around, Coca-Cola says we are no longer going to be using sodium benzoate in their formula. 2012, Coca-Cola still uses sodium benzoate in some of their formulas. Okay? Again, they can do it. They can get rid of it if they want, but they're not required to do it by any government organization. So, of course, they're not going to do it. All right, now that's just Coca-Cola. So let's kind of look at a report now. Let's look at some of the culprits that we are going to see that have violated the benzene industry. And you might be scared. So here's an article straight from the U.S. Food and Drug Administration titled Data on Benzene in Soft Drinks and Other Beverages, data through May 16th, 2007. Oh, well, I thought the FDA said that they would continue to monitor it. This is 10 years old. Where's the current data? Huh. All right. Well, as I read through, because I've got complete trust in the FDA and what they do, and as I read through, maybe they just haven't discovered anything after 2007. Maybe that's the case. So good job. All right, well, it's going to give me a table, and I'm going to scroll through the table, and I'm going to take a look at the found ppb. Part per billion is what that stands for. And remember, 5 is the drinking water standard. So this doesn't mean anything to the soft drink world, but it's kind of a threshold or a hurdle that I don't want to cross. Ideally, 5. Less than 5. And it looks like in the beginning, these are pretty good all the way through. Right? Oh, I see a 3.5 right there. 3.5 Giant Diet Sun Pop. Lot number 1. So they got close. ND means non-detected. So they didn't really find anything there at all. Less than 1 just basically means that's kind of their limit of quantification. So they can say it's less than 1, but they can't really give you a number because maybe their calibration curve didn't go that low, or maybe their instrument is not that reliable to go lower than 1 part per billion. And I'm going to continue to scroll through, and I see a lot of good numbers. But whoa, 79.2? Safeway Select Diet Orange. That's almost 80 part per million. 5 is the cap. And this has 80. Safeway Select Dyed Orange Lot Number 2, 15.2 and 10.7. Same product, different lot number. Different lot number means different time of manufacture. Different batches. Safeway Select Dyed Orange Lot Number 3, 13.2, 11.4. Whoa. So this maybe could have been an older batch, and this one was like a middle-age batch, and this one was a younger batch, maybe, who knows? But those numbers are not good if 5's the cut. So maybe we should stay away from dyed orange soda. All right, so as I scroll down, 3.5. Sunny D, Citrus Punch. That got close. But 9.2, that's above. That's almost double the limit. And that was crushed pineapple. 23.4, AquaCal, strawberry flavored water beverage. Oh no, I was on such a good roll because I'm not a soda drinker and I felt good about my choices and my life choices. But all of a sudden I get flavored water that's thrown into the mix at 5 times the legal limit. Strawberry flavored water. Might want to stay away from it. Strawberry flavored water beverage lot number 2, 10 and 9. Again, double the limit. These get pretty close. Peach mango flavored water, grape flavored water. The general trend here, flavored water, stay away from if you're worried about benzene contamination. I go on down. I keep scrolling. I see some low numbers and some 76.6 and 87.9. Crystal Light Sunrise Classic Orange Lot Number 1. Crystal Light Sunrise Classic Orange Lot Number 3. Again, citrus flavored. But this is supposed to be healthy. This is non-calorie. I'm supposed to be able to drink as much of this as I want to and not gain a pound, right? Well, you're drinking benzene too at it. Do you want the pound? Or do you want the cancer that benzene brings along with it? As I keep scrolling down, 4.8, that gets close. Ocean Spray, light cranberry juice. Oh, God. Giant light cranberry juice cocktail. Double the limit. Giant light cranberry juice cocktail lot number 2. Over the limit. Cranberry juice? High levels of benzene that are present? Kind of scary. All right, well, here's another table, and this is a continuation, maybe of different methods or different ways of detecting it. And then again, I see Diet Safeway Select Orange, double the limit. Diet Safeway Select Orange lot number 1, double the limit. Fanta Pineapple, double the limit. Belly Washers, Black Cherry Blast, Vitamin C Juice Drink, perfect for little kids. 40 part per million. Belly Washer, Black Cherry Blast, Vitamin C, lot number 2, 88 part per billion. You're giving your kids benzene water. How does it make you feel? You thought you were being careful. You thought that you were being healthy. You thought this was a good substitute maybe from soda, and it could be in some ways. But I hope they like rinsing their mouth out with benzene because that's what they're doing. Sunny D orange flavored citrus punch over the legal limit. Sunny D orange flavored citrus punch, another lot number over the legal limit of drinking water. Kool-Aid Jammers cherry flavor over the limit. Are you getting scared? Are sweat beads popping up on your forehead? Because a lot of these substitutes for soda are not any better. 4.8, very, very close. Apple and Eve, light cranberry juice. So you get the drift. Everything is not perfect. No matter what type of product that you're using, no matter what type of product that you're eating, no matter what type of product that you're drinking, there's always going to be a problem with it. Whether that's sugar content, whether that's preservative content, or whether that's benzene content. Of course, some might outweigh more than the others, but you get the picture, right? So that's why I said in the previous video, just enjoy the things that you want to enjoy. You live once. You have a very short amount of time on this earth. So why deprive yourself of things that you enjoy? Why take the time to go through and look at all of the ingredients to wonder what's present and what's not present and what are they putting in my food and what's going on? Because chances are the person that eats the greasy hamburger and the salty French fries, well, their life could be as good and as healthy as yours. And you're just drinking water and eating apples. It's all about limitation. It's all about control. So that's a little bit of background about what you're going to be doing in the laboratory. You're going to be taking sodium benzoate. No, let me take that back. You're going to be taking benzoic acid in the laboratory. No, sodium benzoate. I had it right the first time. Sodium benzoate. And you're going to be adding acid to it in the laboratory, and you're going to be figuring out what type of product is going to get formed. Is it still sodium benzoate? If so, then we're good to go. Is it something different? If it is, then we need to figure that out. So this is going to be part A of the lab. All right. For part B of the lab, it has no relationship with part A at all. Part B of the lab, you're going to have some unknown compounds. And we're going to give you one of them. Or maybe more than one. We might tell you to identify 2 or 3 of them. And this list, or the unknown, will come from a list. And we'll give you the names all the way down. And it's your job to pick out which one of those your unknown could be. And you're going to do that through some chemical and physical properties. Okay? So 2 parts of the lab. Part A, which is the major part, is going to be sodium benzoate. Part B is just the identification of an unknown based on something like density. And that's about it. All right, so go read the lab. Make sure that you understand what you're going to be doing in the lab. Look at the Blackboard lab notes. Make sure that you understand what to change and what to do and what not to do. And then we'll see you in the lab to actually start writing in that very first lab notebook.